Hello, hey everyone, welcome to Sleepy Radiology classes. And I promise it will be easy for you. Hello everyone, welcome back to our classes. And now we are in the QA series. Today is 7th May, so I like to wish everyone happy Budh Purnima. So today is day 4 and we will discuss on focal spot size test. So before we move to our topic, let's just brush our mind about what is focal spot size. Just simply keep in mind it is the area where the electrons strike after coming out from the cathode. Okay, so what is focal spot? It is just the target area in which the electrons strike and it gets absorbed, and it is the main area where we are producing the X-ray. So that is what is called as focal spot or focal area. So what is the main purpose of measurement of focal spot size is just to produce a sharp image and to lessen our penumbra. As if penumbra is more, the sharpness of the picture will be bad and it will give you a bad quality of image. And also larger focal spot areas are very much helpful in removing the heat from the X-ray tube very quickly. Next is, while we design the focal spot size for our tube, we have to keep the following factors in mind. Number 1 is the dimension of the filament tungsten coil. Number 2, construction of the focusing cup. Number 3, position of the focusing cup in respect to the filament. And finally the electric field which is created between the cathode and anode. Next is, what are the various sizes of focal spots we use? So basically we have two focal spot areas. One is the actual focal spot, another one is the effective focal spot. So always keep in mind the actual focal spot will be larger compared to the effective focal spot. So just we will discuss in brief. Actual means what? Original, right? So what is the actual focal spot size? It is just the area from the cathode to the target area, that is the anode, where the electrons strikes. So in short, it is just the measurement of the target itself. So you can see here, from cathode to anode where the electrons are striking is my actual focal spot, and it is what? It is always larger. Okay, and next one is the effective focal spot. An effective focal spot is the length and width of the emitted X-ray beam. What? Emitted X-ray beam produced from the central point of the X-ray tube, and this is always small. So what is the effective focal spot? It is the area after striking of the electron, and it is the length and width of the emitted X-ray beam projected from the central axis of the X-ray tube. Okay, and when we say about the measurement of focal spot size, it is expressed in term of our effective focal spot. So next, there is a relationship to get the measurement of our focal spot size, that is effective focal length equal to actual focal length into sin theta, and sin theta is our anode angle, that is the angle of target, the steep angle mainly. So when we are saying about the X-ray tube, we can now say that it requires two area. One is the larger area, that is the actual one which produces huge amount of X-ray, and then we have the small focal spot area which produces from a point source the sharp image, and finally we have the steep angle. It is with respect to the motion of the electrons, and this thing totally we called it as line focus principle, and line focus is effective focal spot equal to actual focal spot into sine of the anode angle. Next is, our focal spot size is expressed in mm, and it ranges from 0.3 mm to 2 mm. So basically we have focal spot sizes of 0.3, 0.6, 1.0 and 1.2 mm mainly which we used for radiological purpose. And the major effective focal spot sizes are on our special resolution. Next thing is for mammography we use focal spot from 0.3 mm to 0.6 mm, and for radiology purpose, diagnostic purpose, we use from 1 mm to 1.2 mm. So one thing you have to keep in mind, when your focal spot size is small, the spatial resolution will be good, means you can differentiate small tissues very clearly. And basically larger focal spot sizes are used to dissipate the heat very fastly, to prevent tube heat loading, and also it is used for shorter exposure time because time is our priority. So that was all about the focal spots. Let's move to the our today's main topic, focal spot size test. So the main purpose of our focal spot size test is to get the smallest details of the image, smallest detail of the pathology, so that we can get a sharp image and we can get a fine quality details of pathologies of micro sizes, and also to prevent the equipment from the bombardment of the electrons. So that is why we have to check once in a year with a non-screen film the focal spot size. So let's move on how we can check the focal spot size. So basically in older days focal spot size was measured by using such tools which you can see in the images like pinhole camera, slit camera, star pattern. But nowadays we are using the bar test pattern to record our focal spot size image, and this is all the images if we are using the various types of equipment or test tool. So if you want to know about the focal spot size, you also have to know about one term that is known as magnification. So just keep in mind, magnification is nothing but the relation between the image size and object size. So you can see in the image the object and this is the image. Okay, and how we find the magnification? Magnification is nothing but FFD by FOD, focus to film distance by film to object distance, or you can say magnification is image size by object size. So let's move on. So now you can see here, this is our focal spot size measuring tool, and what we require is same. We require an acrylic cylinder and a non-screen cassette. What is the type of cassette? Non-screen cassette. And let's move on. What is the construction of our acrylic hollow cylinder? So this cylinder is having 6 cm diameter and 15 cm height, and this cylinder also has one circular, in the top you can see one circular bar pattern, and this bar pattern is made up of tungsten plate, and this bar pattern has 12 groups of lines, 12 groups of lines of decreasing dimension. So the less number you get, the more quality of image you will get. So as per our query, as per the image, you can have the bar patterns from 0.84 line per mm to 5.6 line per mm. So without any further delay, let's move on to the procedure. So for this procedure, you require a non-screen film cassette. So there you have to remove the intensifying screen, and next is you require the focal spot measuring tool, and then you are going to adjust the height up to 60 cm. No need for 100 cm also. Next thing is you require a pocket dosimeter to measure the dose. Then you can select the kV up to 60 to 70 and MAS within the range of 5 to 8. And for this test, the main important thing is the calculation. So before going to the calculation, we have to expose. So we have exposed the film, and now we will move how we are going to do the calculations after processing. So let's move on how to check the magnification. So we have set our FFD, focus to film distance, 60 cm, and how we can find our FOD, film to object distance. We know that our cylinder was 15 cm in length. So 60 minus 15, how much we get? 45. So next you are going to do is, we know M equal to FFD by FOD. So 60 by 45 is 4 by 3. So we got the result for our magnification. And now next thing is, we are going to look over how we can do the further calculations to see whether our focal spot size is perfect or not. The focal spot, we know that F equal to M, that is magnification by M minus 1, magnification minus 1 into line width. And what is a line width? Line width is nothing but the, in the chart you can see that there are the smallest groups, means how many group we have taken, 1 to 12, they are lines per mm, that is the measurement, and the effective focal spot size. So always keep in mind, at least your range should be within the range of 8 to 12, not above that. If it is above, you have to then and then go for rectification. So that mm size is going to give you the calculation measurement. So here it is the format how we put the calculations, and I showed you how to do the calculations also. Next thing is, this is the results. So you have to keep in mind that you have to bring the smallest resolvable image, that is smallest point which you are going to, or which you are able to see on the image. So that was all about the day 4 focal spot size measurement, and I hope it is now clear to you how we do the measurement, how we do the calculations. So if you have liked my video, please do subscribe, press the like and share it, mainly share it to the persons who require it. Thank you, and from tomorrow we are going to start with the other QA test. So keep following, keep watching. Thank you.